4a. Combining OSM amenities and GEE population data, step by step. The following two courses, 4a and 4b, teach you a combination of the previous courses. You'll extract OSM and GEE data, combine them, and analyze its parameters. By using the capabilities of GEE within Jupyter, you will visualize extracted and manipulated time series data from OpenStreetMap on an interactive Google Earth Engine map. In particular, you'll count, extract, and map electric charging stations in an area within Bochum in Germany. Initial setup. Necessary libraries are imported, this time also GEE-map and EE. The OSM client is used for querying the OSM API to retrieve spatial data. Matplotlib helps in creating visualizations. Pandas is utilized for data manipulation. GEE-map integrates Google Earth Engine with Python for interactive mapping. EE is the Earth Engine library that provides access to GEE's geospatial data and analysis tools. NumPy supports numerical operations. Now, initialize the OSM client. This prepares the client to make requests to the OSM API. Set up Google Earth Engine. In the beginning, authenticate and initialize Google Earth Engine. This process allows access to Earth Engine's vast data resources and tools for analysis. Retrieve charging station data. First, we define the area of interest with a circular bounding box. The coordinates specify a circular area with a radius of 5,000 meters, centered at a given latitude and longitude. For this example, it's a circle around Bochum in Germany. Afterward, we set the date for the data retrieval. This specifies June 15, 2021, as the date for retrieving data, ensuring a snapshot of the situation on that day. This filter retrieves data on charging stations identified as nodes within the specified area. Send a request to the OSM API to get the locations of these charging stations. The response contains the data of charging stations within the specified circular area. Convert the response to a data frame and inspect the first few entries. This step transforms the API response into a data frame for easier analysis and displays the first 5 records. Prepare data for Google Earth Engine. Google Earth Engine requires latitude and longitude in separate columns. Extract these coordinates from the geometry column. Now, remove the geometry column, as GEE cannot process it. To use it further, we must convert the cleaned data frame into an Earth Engine feature collection. Create and display an interactive map with the charging stations using the map function. Now, you can see each charging station within your area of interest. Let's scale this up. Retrieve and process time series data. Define a larger bounding box and a list of dates for time series analysis. The bounding box covers a broad area across Germany, and the list contains dates for historical data retrieval. We now create lists to store API responses and data frames. With this loop, the program iterates through each date while retrieving and processing a relatively big amount of data. And here, we print the number of amenities to get an idea of its development over time. Export data. Save each response as a GeoJSON file so that we can use it later on. This formula only describes the logic behind labeling the files and where to store them. Analyze with Google Earth Engine. For combining both data sets, we must load the most recent data frame into GEE. Now, from GEE, we can add population data to the map. Let's use the POP GPW Globe dataset. You can now trigger different layers within the map to see visual connections of the datasets. Finally, we create an interactive map where you can use the inspector tool, the eye symbol under the map settings in the upper right corner, to get information about the features by clicking on them. The pop-up window will give you all statistics we just calculated for each administrative unit, which are federal states in this case. At this point, it is possible to calculate the valuable statistics of this combined dataset. For that, we define count region and add a few calculations to the function to make the output more comprehensible later on. Let's finally display the results on the map. Export final results. For exporting the analyzed data as a shapefile, simply use the EE to SHP function. You can also export the data as a GeoJSON. However, note that this might have issues with complex polygons. If you want to export the data to your Google Drive, you can use the EE to Drive command. For this, you can also specify the location within your Google Drive account. This applies to all of your work. As long as you have the space within your drive, you can export your findings there. This script demonstrates how to retrieve, process, and visualize spatial data using both the OSM API and Google Earth Engine, incorporating historical data analysis, mapping, and exporting results. Script 4b offers the same workflow as 4a, but is not explained step by step. In the beginning, it gives you the chance to change the variables as desired for your program to execute on a different spatial or temporal extent.